All right, the midpoint theorem says if M is a midpoint of AB, so what we do is we have a segment, which I'm not feeling capable of drawing straight lines right now, so I have a segment, right? And I have A and B, and M is the midpoint. Okay. Well, we already knew that if M is midpoint, that meant AM and MB were equal. Well, now we also say they're equal, but they're also 1/2 of the whole thing. So what we did is we took what we knew about midpoints and we made it into an official theorem. So AM is equal to MB, which is 1/2 of AB. They're all the same, interchangeable. Okay, common segment theorem. Okay, so again, I'm going to have a segment drawn. And I've got R and U. And then in the middle here, I'm going to have S and T. Okay, if RS and TU are the same length, so I'm going to mark those red. RS and TU are the same length. Well, that would mean that RT and SU are the same length because you've added ST to both of them, right? So this adds ST. Oh, I should probably write that in a color you can read. And you can go the other way. If RT and SU are the same size, then RS and TU are the same size. This one is subtracting ST from both. Both is with a B. So we're going to prove this, the first part. So we're proving if then from A. Okay, so I have RS is congruent to TU, that's given. And I'm going to label it RS is congruent to TU. That means that the measures, okay, when we talk about segments, remember I mentioned that this is the actual segment. And if I don't have the line over it, this is the length. Okay, so this is telling me the length of RS is equal to the length of TU. So that's the definition of congruent. Okay, ST is equal to itself. When things are equal to themselves, yeah, they're reflexive. Now I had to put this step in here because this introduces ST. ST didn't exist before. We didn't have it, so we had to introduce it. And to introduce something that's not already there, you just say it's equal to itself, and then it's introduced. RS plus ST is equal to TU plus ST. It's addition. I'm adding the same thing to both sides. And then RS plus ST gives me RT, and TU plus ST gives me SU. That's segment addition. And the difference between addition and segment addition is here I'm just adding the same thing to both sides, and here I've actually added the two parts to make a bigger part. And because they're equal, they're congruent. That's the definition of congruent. Well, I've got that DF is congruent to EG, so immediately I'm going to go ahead and label that. I'm going to put these picture like that to show me that those two are the same length. So DF and EG. FG is 16. EF is 4. And I want to find DF.
So 20.
Yeah, 20. So if these are 4 and 16, that's 20, right? And this is the same length as that, so 20. So 4 plus 16 equals 20. That gives me EG, which is also equal to DF.